All right, the Pythagorean Theorem. A few review problems. Okay, so first off, if you look at this problem, we need to evaluate the numbers. So 13 squared is 169. And 25 squared is, 625. Now, to solve for x, we need to get it by itself, so we're going to subtract 169 from both sides, which gives us x squared equals 456. And now we need to square root both sides. Now, of course, we could just turn that into a decimal, and that decimal is an approximation because 456 is not a perfect square, right? So we need to look for numbers that are perfect squares that go in to 456, right? And when we do that, it ends up being 4. Small numbers, sometimes they're bigger, but it's only 4 times 114. Now remember, that's square root of both of these numbers. Then we're going to take the square root of this number, because it is a perfect square, and get 2 times the square root of 114. This is an exact answer, right? Even though we don't talk in terms of radicals in real life, turning that into a decimal is, people think is an exact answer, but it's not. This is exact. Turning it to a decimal would be an approximation because you're rounding. Okay, number 2. Remember, whenever we have a square root squared, that actually undoes this. So this is just 5 plus x squared equals 144. When I subtract 5 from both sides, I get 139. All right? Now, when you check and look for a perfect square number that goes into 139, there is not one. So it is just the square root of 139. That's it. You can't simplify it. So let's talk about the Pythagorean Theorem. Pythagorean Theorem only applies to right triangles. That's very important. It has to be a right triangle. And what we have here is a leg, and opposite the right angle is the hypotenuse. I really suggest you get in the habit of putting that arrow from this, shooting to the opposite side. That is the hypotenuse. You need to know where the hypotenuse is. Okay? And the formula is simply, you square the legs, add them up, and you get the squared hypotenuse. So let's see how it works in real life. So I'm going to draw my little arrow from the symbol because it's very important to know where C is. These two are interchangeable. It does not matter, okay? But C is very important. So I always suggest you do this every single time and then fill in your numbers. So 5 squared plus 12 squared equals C squared. So 5 squared is 25, 12 squared is 144. And when you add those together, you get 169. And when you square root both sides, you actually get a whole number, 13. 169 is a perfect square. So this is 13. Now, 5, 12, 13 is what's called a Pythagorean triple. Here are some common ones, okay? These are all numbers that form a right triangle. So find the value of x, tell whether the side lengths form a Pythagorean triple. Well, if you look up here and look for 7 and 14, okay, it's not on there, but that doesn't mean it doesn't work. Okay, so here's the important thing. Remember I said always look and see where the right angle is to the hypotenuse? The most common mistake here, and don't write this down unless you're going to say no, is to do this. 7 squared plus 14 squared equals x squared. And that's a big no-no. Because this is my C. These are my A's and B's. So a squared plus b squared equals c squared. Start like this every time. Fill in what you have. We don't know this, so we leave it as a variable. We could leave it as b squared. It doesn't really matter. All right, equals 14 squared. All right, well, this is 49 plus x squared equals 196. Let's subtract 49 from both sides. That gives me x squared equals 147. Now, that is not a perfect square, but it does have a perfect square number trapped inside, and that's 49 and times 3. So the perfect square 49 becomes 7. Square root of 49 is 7, and the radical 3 stays. So the answer is not a triple, because the triples are made up of whole numbers. All right, example 3. The skyscrapers shown are connected by a skywalk with support beams. Use the Pythagorean theorem to approximate the length of each support beam. Okay, so we only have to deal with one of these triangles. Now, one thing to pay attention is this 23.26 here, that's each side. So you see how they have the arrows to it? So this right here is 23.26, and this right here is 23.26. So you don't have to divide that by 2. Each one of those is. So again, I like to draw this. So this is my C, or my X, doesn't matter. This is my A, and this is my B, again, interchangeable. So A squared plus B squared equals C squared. So 23.26 squared plus 47.57 squared equals x squared. Now notice it says approximate. That means we are going to get to just round this, get a decimal answer. We don't have to simplify. And that would be nasty because it's a decimal anyway. I'm just going to skip ahead. When you square these and add them together, it's 2803.9325, if you will. So we square root both sides. We type that in the calculator, we get 52.95. Again, that's approximately meters. Now the converse, again, is just going the opposite direction, is saying if a squared plus b squared equals c squared, then we know this is a right angle. So this is kind of going backwards. C is always opposite that angle. So we're trying to see if C is the right angle. So we test it. Okay. Also, it's always the longest side. So if you're not sure what the longest side is, especially when you have radicals like this, real quickly, just take your calculator, do the square root of 113. Whoops, sorry about that. Don't know what happened there. 113. And you get approximately 10.6. Okay? What that means is this is my C right here. That's the angle we're looking for my right angle. The hypotenuse is always the longest side. Right? So when you can't tell by the shape of it, it's close, and you need to convert it to a decimal, that's fine. You can clearly see that this is the longest side here. So this is my C. But we could type in 4 times square root of 95, find out what it is, and it's going to be bigger than 15 and 36. So what we do is we do 7 squared plus 8 squared equals the square root of 113 squared. Now, remember, anytime we have this situation, that goes away. So what we got is 49 plus, 64 equals 113. We get 113 equals 113. Check. That's a horrible right angle. So the answer is yes. This one over here, 15 squared plus 36 squared equals 4 times the square root of 95. Now, got to be careful here That's squared. All right? So gotta slow down here a little bit. So this is 225 plus 1,296. That's going to end up being 1,521. Now on this side, you got to be careful. You have to square the 4. 4 times 4 is 16. But remember, this still is going to cancel that out. So that's 16 times 95. So let's see what that is. 16 times 95. 1520. Really close, but not exactly. So that's a no. All right. Pythagorean Inequality Theorem. All right. For ABC, where C is the length of the longest side. Now notice, lowercase c. The following statements are true. If the legs squared and added together is bigger than c squared, it's an acute triangle. If the legs squared and added together are smaller, less than the longest side squared, then it is an obtuse triangle. Right? So we're not looking at right angles, obviously, but we have this comparative situation where we have to add the numbers up and see what we get. Okay, the triangle inequality theorem. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. So let's go ahead and do a practice problem here. Verify that segments with 4.3, 5.2, and 6.1 form a triangle. Is a triangle acute, right, or obtuse? All right. So remember, it doesn't matter A and B. Those are interchangeable. But this is the longest side, so it has to be C. So we're going to do A squared plus B squared and C squared. We're not really saying equals. We're just comparing. So 4.3 squared plus 5.2 squared and then 6.1 squared and see what we get. Okay, well, when we square these and add these together, we get 45.53. When we square 6.1, we get 37.21. That is greater than. Okay? Therefore, we have an acute triangle. So again, when the legs squared and added together are greater than the longest side squared, we have an acute triangle. And there we go. That's it.